Hello my dear students, I am Divyam and I am welcoming you all in another video. In this video we are going to see the directive influence of these functional group in benzene. So I have written few of the organic compound and there are different types of functional group attached on the benzene ring. So first of all, let's understand the resonating structures of these compounds, and then we will discuss the influence of these functional group on the benzene ring. So let's start with the very first phenol. I have written here. As you know, there is a lone pair on oxygen, and this lone pair come inside the ring and circulate within the ring, and so that we can draw different types of resonating structures here. So as it moves inside the ring, this double bond pi electrons of this double bond will shift on this carbon. So here on the carbon number 2 we will be having negative charge, and now here there will be a double bond with OH, and oxygen is having one positive charge with one lone pair, and rest of the double bond I will form it like this. Now again there will be a circulation. This double bond move toward this double bonds electron move on this carbon, and this electron lone pair and the positive charge will form a bond here again. So we will be having one double bond here with negative charge here, and rest of the lone pair and positive charge is same. Again there will be a movement of this double bond electron towards this carbon, and this will move forward, and now this carbon is having what? Negative charge, and we will be having same as oxygen with the lone pair and positive charge, and the double bond is like this. Again what will happen? This double bonds electron will shift on the oxygen, and this comes here and form a double bond like this, and here we get the same structure, but there is a change in the position of the double bonds. You can see here the double bond lies between carbon number 1, 2, 3 and 4, 5 and 6, but here you can see the double bond lies in the carbon number 2, 3, 4, 5 and 6 and 1. So these two are resonating structures of each other. So as you know, chlorine is having lone pair. So this lone pair again comes with the inside the ring and form the resonating, we will form the resonating structures here. But here what happens, as you know, chlorine is more electronegative as compared to carbon. So chlorine shows minus I effect, but yes, the lone pair of the chlorine shows what? Due to this it shows plus R effect also. But if we compare the inductive and resonance effect, inductive effect and resonant effect, the resonance always dominates the inductive effect. Here this due to this lone pair, this OH group is showing what? Plus R effect here also. Alright, so we will draw the resonating structure same as above, that the lone pair comes inside the benzene ring. We will be having this shifting of electrons from the double bond, chlorine having positive charge, here we will be having negative, and so on. The structure will be same as above. Again, there is the movement of this. We'll be having negative charge here, double bonds here, then chlorine with positive charge here. Again, there is a shifting of this electrons on this carbon. Then we will be having negative charge on this, double bond here, chlorine with positive charge. Then there is a shifting here, and this we will be getting what? This. Okay, again, this is the resonating structure. You can see in the structure first and the last, there is the shifting of double bonds here. Now here what happens in this compound, this NO2 group shows minus R effect. Minus R effect. So what it does, it withdraw the electron density from the benzene ring towards the oxygen. So what we are having, we will be having that there is a shifting of this pi electron towards oxygen, and due to less electron density here on the nitrogen, this nitrogen pulls the electron density from the ring. So if we draw the resonating structure here, we will be getting what? A positive charge here, a positive charge here, a double bond here, and here oxygen is having negative charge, the lone pair. All right, and rest of the double bond is like this. Again, what is going to happen, this pi electron will shift toward this side, and we will be having the positive charge movement here, double bond here, this nitrogen, oxygen having negative charge with the lone pair. Again, what is going to happen, this charge will move here, sorry, electron will move here and the charge will move here, nitrogen, and the double bonds here and here. We are going to have our structure with 3 double bonds. This nitro group shows minus R effect. Now in this particular group, this CH3 shows a hyperconjugation. Okay, hyperconjugation, and we call it hyperconjugation as no bond resonance also. All right, but due to this hyperconjugation, the electrons of one of the carbon hydrogen bond makes the resonating structure and revolves in this benzene ring. So let's see how it happens. I will draw this again here with the carbon having hydrogen and hydrogen with the double bond here. So one of the electron move inside the ring and it forms a negative charge here with the double bond, carbon, hydrogen. Here it present like this. There is a no bond. That's why we call it as no bond resonance. The hyperconjugation is known as no bond resonance because one of the electron move from here and then density increases on the ortho and para positions. So now let's have a discussion about these electron density and the positive charge in the ring. So here you can see that due to this plus R effect, the ring is having minus or you can say electron density on its ortho and para position. As you know, if any group is attached here, let's say OH is attached, in respect to this functional group, this position and this position we call it as ortho, this position and this position is meta, and this one is para. So if the electron density increases on the ortho position and para position, we call that particular functional group as ortho-para directing. And if there is a decrease of electron density on ortho and para positions, that group we call it as meta-directing group. So here you can see that this OH group increasing the electron density on ortho and para position. Ortho, para, ortho. So if any of the electrophile is going to attack on this phenol, if any of the electrophile is going to attack, so it can easily attack on what all positions? On the ortho position, and can attack on para position, because the electron density is more on ortho and para position. Alright. Now come here and let's see, if the chlorine is attached to the benzene ring, again there is an increase of electron density on ortho, then para, and then ortho. So again, if electrophile is going to come and attack on the on this chlorobenzene, so it will attack on ortho and para position, But if we compare the phenol and chlorobenzene, the electron density more will be in case of phenol, because here only plus R effect is affecting here. But here you can see, due to this minus I effect, as compared to phenol, some of the amount of electron density will shift toward chlorine also. So if we compare these two, the electron density more in case of phenol on the ortho and para position, and less in this case. That's why we call it as deactivating group. We call chlorine as deactivating group. Alright. And we call OH as activating group, because it purely activates the benzene ring. But here, due to this minus I effect, it is somewhat deactivating the ring. But yes, plus R is dominating over inductive effect. That's why we call it as a ortho and para directing group, chlorine. Alright. Now if we see this NO2 group, NO2 withdraws all the electron density from the benzene ring, and here you can see on the ortho and para position, ortho and para positions, there is a less of electron density. So if any electrophile is coming and reacting with this nitrobenzene, it will definitely go on which position? Meta position, because as compared to ortho and para, meta is having more electron density in the case of nitrobenzene. So here this nitro group, what? This nitro group is again what this is doing? Deactivating the ring. It means it is withdrawing the electron density and decreasing the electron density from the benzene ring. That's why we call it as deactivating group, and also we call it as meta-directive. It means if any electrophile is going to come and attack here, it will attack on meta position. That's why we call it as nitro, as a meta-directive group. Now here you can see the toluene. What you can see again, it is also an ortho para directing group, because this is also increasing the electron density on ortho and para position. So again, same thing will happen if electrophile is coming and it have to attack in this toluene. So it will attack itself on the ortho, either on the ortho or para position. All right. So this is an also what activating group. This methyl group is also an activating group. So know one thing that about the group, that what type of effect it is creating. Plus R effect, minus R effect, minus I effect, plus I effect. So you need to know about these things so you can easily answer the questions. Now here I have written 2 questions, and these 2 questions are from your NCERT. One question is, out of benzene, meta, nitro, benzene and toluene, which will undergo nitration more easily? So you have to answer about this question. So you need to draw the structure here. So here benzene I had drawn. Now meta dinitro benzene, NO2, NO2, and one more here is toluene, CH3. And you have to answer that which one of these 3 is going to undergo nitration very easily. So you know that in nitration, NO2 plus nitronium ion is the electrophile which is going to attack. So let's say it's an electrophile and it has to attack here. So as you know that CH3 is what? Activating group. It will activate and increase the electron density on ortho and para position. Alright. But the nitro group is what? Deactivating group. It will withdraw the electron density. So first of all, let's see, we see this nitro group. So it will decrease the electron density from its ortho. So this ortho position and para position. It will create the positive density here. All right. And now if we'll see this nitro group, this is also creating the, or you can say withdrawing the electron density towards self and creating the positive charge on its ortho and para position. So if electrophile has to come, so it will having only one position here which is having electron density, and this electrophile will attack here only. It means if benzene is having 2 nitro group, this is giving only one space to attack the electrophile here. And now in benzene can show the electrophilic substitution reaction. Know any group which is facilitating the addition of this nitro group. So this will go the nitration very easily, then this, and then at last this. So the order will be toluene, then benzene, and then dinitrobenzene. All right. Now here the second question is, in which we have to compare the chlorobenzene 2,4-dinitrochlorobenzene and para-nitrochlorobenzene. All right. So let's draw here. First of all, we have to draw chlorobenzene. Then 2,4-dinitrochlorobenzene, 1, 2, NO2, 3, 4, NO2, and para-nitrochlorobenzene, para-nitrochlorobenzene, and we have to compare that. Arrange the following set of compound in order to their decreasing relative reactivity of an electrophile. Means which will give decreasing relative reactivity with an electrophile, means which is going to react less with the electrophile. So as you know, this chlorobenzene shows what? Minus I effect and plus R effect, means it is increasing the electron density on the ortho and para position, but yes, there is a minus I effect also. So if we compare this with the purely with that functional group which is increasing the electron density only, it means only plus R effect. So in that comparison, there is a less of electron density on its ortho and para position. Here let's see, this chloro group will increase the electron density here at ortho and para position. This nitro group will decrease the electron density on its ortho and para position, and this nitro group is also going to decrease the electron density on ortho and para position. All right, so there is only one room for the electrophile to come and attack here. Now let's compare this. This chloro will increase the electron density on its ortho and para position. Nitro group will decrease the electron density on ortho and para position. So here two space is here where the electrophile can come and attack. So in this there is three positions, in this only one, and here two. So electrophile will relatively less react in this case as compared to this and then this. So this, the order will be, this is on the first number, then second, and then third. All right, now there is another question. I hope this you can do by your own. So do try, and if you have any doubt, do ask me in the comment section. And this is all about today's video. And thank you for watching, and do like, share and subscribe my channel. Thank you so much.